So very good morning to all. Myself Anand. I am working as assistant professor in the Department of Mechatronics Engineering past 10 years. So I am handling electrical electronics BEEE basics electrical electronics engineering subject for first semester first year mechatronics students. So in that we are going to discuss about the topic of electrical circuits, in that the mesh analysis unit 1. So today we are going to discuss about the basic concept of DC circuits, that is uh, so we have two types of circuit, that is AC circuit and DC circuit. Circuit is nothing but it is a representation of every equipments in electrical method, and key components and Ohm's law and Kirchhoff's law. So what about DC circuit? DC circuit is nothing but the flow of current in a single direction in an entire circuit is called DC circuit. So it have only DC plus minus power supplies, and it has some current, that is I1 I2 I3 based on the loops and resistance, and some of the coil and load components, coil and capacitors. And key components are conductor, resistor, inductors and capacitors. Here conductor is nothing but it is a medium transfer the current from one side to another side. A resistor is a device which is opposed the current flow in a circuit. So based on the resistance value, it has some current opposition powers. And then inductor capacitor is the storage device. Inductor is nothing but it is for current stored device. Capacitor is voltage stored device. So and then Kirchhoff voltage law. So before the going to the KVL law, we have some basics law, that is Ohm's law. So according to the Ohm's law, when a steady state condition, the current flowing to the conductor is always perpendicular to voltage, that is V directly proportional to the R. So we have recreate the Ohm's law as V equal to IR. Here R equal to constant. So V is nothing but the input voltage. Here I equal to current, R equal to resistance. So coming to the Kirchhoff voltage law, that is short form of KVL. The sum of all the voltage around the closed loop is equal to 0. So topics for discussion: mesh analysis, step to step perform mesh analysis, and sample problem solutions, real world applications of mesh analysis. So we start from mesh analysis. What is mesh analysis? Uh, Here, before going to that, what is circuit? This is called a circuit. In this circuit we have input supplies, that is plus minus. So this is DC supply, DC circuit. So we have only DC supply here, but in the circuit have two supplies here, source 1, source 2. So voltage source 1 is called V1, voltage source 2 is called V2. So uh, this entire loop is called resistance 1, resistance 2. So combination of V1, resistance 1, resistance 3, again voltage source. This closed circuit is called loop 1. Likewise V2, this resistance, again V2. This closed circuit is called loop 2. So we have two loops. In the method to analyze DC circuits by applying Kirchhoff voltage law to mesh current in planar circuits. So why KVL, Kirchhoff voltage law is very much important? A loop does not contain any other loop in it. This is one of the basic need of mesh analysis. What is the purpose of mesh analysis? Simplify the simplifies solving for unknown current in complex circuits. So for example, this is a, you take it, this is a complex circuit. With the help of KVL, Kirchhoff voltage law, you can easily find the current and voltage in a circuit based on Ohm's law. It will be very much useful for analyzing and measuring and determining the power taken from the circuits and application of that circuits. So what are the key advantages? Reduces the number of equations compared to the nodal analysis for certain circuits. So coming to the step 2 performance mesh analysis, you take this sample circuits. In the circuit have two sources. The sources one is V1, the source 2 is V2. So source 1 have 130 voltage, that is V1 V2. This is loop 1. This loop we have two resistance, resistance 1, resistance 2. So every current flowing to the circuit or loop clockwise, that is clockwise. Here I1 current flow in the loop 1, I2 current flows in the loop 2, I3 current flows in the loop 3. So we have 5 resistance. Just name the resistance R1, R2, R3, R4, R5 from left to right. Just you name the resistance value. So all the circuit, uh, you are going to reduce the method of mesh voltage and current law with the help of Ohm's law, V equal to IR. First, identify the meshes. Determine all mesh loops in the circuit. So we have one loop, two loop. Totally, we have three loops. And assign mesh currents. Assign the clockwise current. Example I1, I2, I3. So this is I1, I2, I3. And apply KVL rule. Write KVL equation for each mesh. Summing voltage drop across the components. So solve the equations of linear equations to find the mesh current. So we have voltage. Yeah, the basic objective is to determine the voltage of current of every loops. That current was um, mapping with Ohm's law to determine the resistance value. Calculate the branch's current. Use mesh current to find the actual current in the branch if needed. So finally you get the value of voltage, current and resistance. So just you take this problem as a sample program, that is solve the mesh and branch current shown in circuits. So we have two nodes. So node 1, node 2. In this node having uh, voltage source, that is V1. Another node having voltage, second voltage source, that is V2. So we have resistance 1, resistance 2, resistance 3, three resistance. The current I1 in loop to I2. This is the sample circuit. Just you take it as a two loops. Just name the every corner nodes A, B, C, D. The first loop, take it as a B, C and then A. This is loop 1. The second loop is B, D, C and then B. Just first assign the mesh or loop current to the two meshes, that is ABCA. So ABCA and then BDCA. So based on mesh analysis, we have two equations, that is one is 120 equal to 40i minus 10i2 and then minus 240 equal to minus 40i1 plus 240i2. So just multiplying equations 2 by 4 and adding the equations 2 in equations 2, we get the value of minus 120 equal to 230i2. So again you simplify this equation, I2 equal to minus 130 divided by 230, you get the value of amps, that is I2 current 2 minus 0.521 is the I2 value. The negative sign indicates the direction of the I2 anti-clockwise. The value, this value is substituted in equation 1, that is 40i1 minus 10 minus I2 of the I2 value, that is minus 521 equal to 120. Then you get the value of I1 value. So finally with the help of KVL law, you get the value of I1 I2 with the help of Ohm's law. The solution is actual direction of the flow of mesh current is shown in this figure, that is I1, I2. So mesh current is I1 equal to 2.869 amps, I2 equal to 0.521 amps. The current branch is CAB, that is CAB is I2 0.521. The current in branch BC is I1 plus I2, that is BC. Here is the resistance value common to I1 and I2. So here 2.869 plus 0.521 equal to 3.3a is the common value. Thank you.